Well, friends, hope you are regularly practicing these basics that are primarily required for understanding the calculus. We have already understood various concepts starting from the Cartesian ordered pairs, and then from the Cartesian ordered pairs, you learned how to make relations. From the relations, you understood how to define a function. So now we have come to a stage where what a function is we understood. Today, our target is to touch the fundamentals of limits. Before going to this, what is the aim of today's class that I would like to just describe? Our aim is now to first understand the continuity of a function. This we should learn today. We are also supposed to understand what is meant by right hand limit, then left hand limit of a function of a function. Then we also are supposed to understand in limits there are two theorems. Extreme theorem is there and intermediate theorem. These are all the concepts. Today we try to see, first we'll give basic definition for the limit and then we will stop. In the next video I will cover all other things, properties of limits, corresponding theorems, etc. Now here I would like to bring one important point called as f of x is equal to, let us say, I have a function x square. This function, when you want to plot it, how will you plot? You will write x here, you will write f of x here, you will give some values 1 1, so starting from 0 0 0 1 1 minus 1 1 then 2 minus 2 4 plus 2 4, like that. All positive values you will get it. So when you plot this graph, it looks like this. This is known as parabola. This is a function. This function, we want to know whether it is continuous or not. What do you mean by continuous? There should not be any break in the function anywhere. If there is a cut or there is an abrupt change in the function value, then it is said to be discontinuous. Most of our daily life problems, they are all functions only. See, for example, I want to know the fluctuations in blood pressure throughout the 24 hours for someone in the hospitals. Fluctuations in BP for 24 hours record I wanted. So this is a continuous curve. Fluctuations in blood pressure, if you want to draw, so you can draw all the 24 hours time in the x-axis, here BP on the y-axis. So whether it is fluctuating or is it remaining constant around the permissible values. So by seeing this curve, you come to know whether it is discontinuous or continuous. Suddenly, if BP is rising from one level to other point, from the normal to high, then you will come to know whether there is a peak or there is a dip in the blood pressure. So from the data of the functions, we will be able to know what is the behavior of the function at each interval, at each point. Okay. So now all the functions, when we are talking about these functions, you know very well, they are bounded by two words. Two words, one is called domain, another is called range. So now what we do, we will plot a graph between the domain and range. Domain and range only will plot the graphs. We plot a graph between, let us say, one graph like this. It is called y is equal to x graph. So domain is all 1, 2, 3, 4, 5, 6 you can put. 1, 2, 3 range side, you can put some values. This function, again, is it continuous or not? How to see? You can see clearly it will go to infinity both sides without any break. So this is a continuous function. There is a simple test to check whether a function is continuous or not. That is called as vertical line test. Vertical line test, what it will do? On the graph, you will plot one vertical line so that it will pass through the graph. Right now, this vertical line is passing through only one point. Is it not? So it is intersecting only at one point. So this curve or this function is called as the continuous function. Let us understand what does it mean. At P, there is one x coordinate and one y coordinate. What does it mean? It means that the point in the domain is having a unique image in the codomain. That is the meaning of this. So this function is called that time 1 to 1. So this vertical line test, if it is cleared by the function, you can confidently say that this is a continuous function. And all the points in the domain are having unique images. This is called 1 to 1. On the other hand, if I am having, let us say, one ellipse or circle, and I have drawn one vertical line. See what is happening here? This ellipse is intercepted at 2 points, P comma Q. So it is having at P one y coordinate and at Q also another y coordinate for the same x value. So x1 here, y1 you write down, y2 write down. So coordinates of P here are x1 comma y2. For Q, x1 comma y1. What does it mean? In the domain, if x1 is there, it is seeking two images. They are y1 and y2. So this is not a function. Not at all a function for us. Because it's having multiple images. It should not be. Now, this is okay for us. Like, for example, in the domain, I am having, let us say, x1, x2. Here I am having y1. Both x1 and x2 can seek same image. That's not a problem. But one element of the domain should not have two images. That is the problem. So now here, let us say, for example, I am having one parabola and you have drawn one horizontal line here. What does this do? This horizontal line is intersecting the curve at two places. Let us say this is x1, this is x2, this is y1, this is y2. 2 points are there. So x1, y1, x2, y1. So y1 is the constant here. In this function, y1 remained constant when for different values of domain. So here x1, x2, y coordinate remains same. So horizontal line test says that this is not one-to-one function, but this is called as onto function. This is also a function. This is also a function, but here this is onto function. So previous slide we have understood what is one-to-one function and what is a function. Their continuity you have checked by drawing one vertical line. That is one-to-one function we have defined. Here we are drawing one horizontal line and telling that this is onto function. Now we'll understand the continuous function. Continuity or continuous? Continuous function. Continuous function means, as I told in the beginning, it should not have any cuts in the path. Suppose if I'm defining a function of this kind, this is a continuous function. If the same function is, let us say, going like this and not defined here, but again defining after this break. So this function is not continuous. This is called piecewise function. Piecewise function. This is continuous function. Continuous function will be continuous within the domain anywhere. So in this case, what is the domain for me? From here to here. If I drop a perpendicular, let us say this is A, this is B. So my domain is in the between A and B. What is my range? So at A here origin is there, and here one more point is there. So let us say this is y1. So 0, y1. So between A and B, whatever is there, for every point between in the interval within AB, if I find out the function's value, it should be continuous. So continuous means there should not be any break. So to know whether a function is continuous or not, there are two tests. One is called as at what point we want to test the curve. At what point we want to test the curve. Let us say I want to test x is equal to 0, one curve. So to know whether a curve is at x is equal to 0, continuous or not, what I will do, I will approach 0 from the left hand side and I will approach this 0 from the right hand side. So around the neighborhood of 0, I will choose one small distance -1. Let us say here +1. So between 0 +1, I will travel. From +1, I will slowly come towards 0. And again from -1 also, I will come slowly towards 0. So limit x tends to 0 minus. Minus means what? I am approaching from minus side of f of x. If it is equal to limit x tends to 0 plus f of x, then what we'll be getting? We'll be getting, let us say both the values are same, for example. Limit x tends to 0 minus f of x. If it is equal to limit x tends to 0 plus f of x, and if both are equal and also the value of function at 0, value of function at 0, all should be equal. So this is equal to, let us say, f of 0, then function is continuous. Function is continuous. So this is very important definition for us. To know whether a function is continuous or not, let us say at this point I want to know in this neighborhood. Then I will come this side little distance from this point of continuous checking. Then measure the value towards A from the negative side, towards the A from the positive side, and try to know whether the values are remaining same. If they are not equal, then function is not continuous. So this is an important test for us, which is going to define the differentiability also. What is the need for this continuity checking? The need is because within the domain we are checking this continuity. Suppose if there is an abrupt change in the variable, that will tell us whether to use that one as an input signal or not. Certain circuits or certain control systems will be there. These control systems, they accept certain inputs. Some inputs they cannot accept. So by understanding at these boundaries, we will come to know whether the function can give me response or not. This is called behavior. Behavior of a function can be studied from the behavior of a function can be studied by checking the continuity. By checking the continuity. So now I must know what I am asked to do by seeing the sum. Suppose they gave me f of x is equal to x square. They said that check whether function is f of x is continuous at 2. So that means what I will do, I will try to say limit x tends to 2 minus f of x, I will find out. And then I will also evaluate limit x tends to 2 plus f of x. Then I will directly substitute 2 in the given equation. F of x is equal to x square. So this is my first one, this is my second equation, and this is my third equation. If all these equations give me same value, then function is continuous. All sums we have to do like this only. So first we should know at what point they are asking us to check the continuity. Then go to the basic equation. If required, we can you simplify the equations sometimes and then substitute also. Then arrive at the limit from both sides. One is called LHL. This is called left hand side limit. And this is called RHL, right hand side limit. And then all the three, that is function value, F2, we have to finally substitute x is equal to 2 and get f of 2. That is third equation. So if 1 is equal to 2 is equal to 3, then we can say that the function is continuous at x is equal to 2. All the three equations should give me same result. So dear friends, I will conclude this video here, and then I will post in the next video the sums which are going to once again brush our fundamental on the continuity areas, because in limits we are having what you are two, three important theorems are there. One is called intermediate value theorem and extreme theorem. First, I will discuss the continuity checking of the functions by you doing 2, 3 sums. Then I will go to the both the theorems, and then only we will be able to go to the differentiability of the functions. So I will conclude the video here, friends. Please see my previous videos further so that you will get a very good idea of what function is. Today we have entered into the function theory. So let us meet in the next class. Thank you.